Hello again. Welcome back to my house where I am talking about math and you are listening about math. It's very exciting for everyone. Today we are going to talk about parametric equations, which sounds fun. Parametric equations are a little bit different from our other equations because they use a separate parameter, which is a word that you may or may not be familiar with, and that's okay. Whoa, it's really blurry. Let's refocus there, phone. There we go. So today we're going to talk about a couple things, actually a few things if we want to be technical. What are parametric equations? How do I graph a parametric set, such as this one? And how do I write a parametric set as a rectangular equation? So I'm sure that these are all things that keep you up at night, and today you will be able to rest easily because you will now know what parametric equations are. So parametric equations are a little bit different from our normal equations. We are used to y being dependent on x. So we're used to having something where y equals x plus 2. In this case, y is the dependent variable and x is the independent variable, and x determines what y is. This is our common form of an equation. This is not what we are doing when we deal with parametric equations. In a parametric equation, we have something that says, for example, x is equal to t, and y is equal to 2t minus 1. So in this case, x is not dependent on y, and y is not dependent on x. X and y are both dependent on t. T is our parameter, and our parameter is what changes, and it changing determines what x and y will be. This gets used in a lot of different situations where you have multiple things dependent on one parameter, say time. So we see it in a lot of different applications, particularly in business. But right now we're just going to be working with the algebra of the situation. So if we wanted to graph something that looks like this, x equals t and y equals 2t minus 1, we would assign a bunch of values to t. So we might use -2, -1, 0, 1, and 2. And we are going to use those values to find out what our x value is and what our y value is. Well, our x value is always equal to our t value, which means that we have -2, -1, 0, 1, and 2. And our y value is equal to 2 times -2 minus 1. So 2 times -2 minus 1 is -5. 2 times -1 minus 1 is -3. 2 times 0 minus 1 is -1, then 1, and then 3. Now, this is going to behave mainly how a linear equation would normally behave, because we're really making t and x be interchangeable. So this could really just as easily say y equals 2x minus 1. So we could graph the points x and y, and we'd end up with a line that has a slope of 2, and it would have a y-intercept of -1, and it's what you would be used to seeing. But let's look at something that's a little bit more challenging. Let's say that x is equal to t minus 2. And let's say that y is equal to t squared plus 1. We are once again going to set our parameters, and let's use the same values for t. Let's say that t is going to be -2, -1, 0, 1, and 2. Then x would be -2 minus 2, which is -4. Y would be -1 minus 2, which is -3. 0 minus 2 is -2, -1, and 0. Y would be equal to t squared plus 1. Well, -2 squared plus 1 is going to be equal to 4. Or sorry, 5. There we go. That's what I intended to write. -1 squared plus 1 is going to be equal to 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. And 2 squared plus 1, note that we're going back to this value. 2 squared plus 1 is going to be equal to 5 again. So if we were graphing this, we would have a point that is at -4, +5. We'd have a point that's at -3, 2, -2, 1, -1, 2, and 0, 5. And this would be our graph. It's a parabola that's based off our parameters. Now, we don't necessarily have to have y be the thing that's doing interesting things with t. We can also have x be something that's doing interesting things with t, and we could make something that looks a lot more interesting than just a basic parabola, but that's what we made here. Now, if we want to turn this thing into rectangular form, let's look at this example. Well, we know that x is equal to t minus 2, and we know that y is equal to t squared plus 1. If x is equal to t minus 2, then x plus 2 is equal to t. And this t right here is the same as this t right here. So we could take that value and substitute it in. So we could have y equals, instead of a t, we'd write x plus 2 squared plus 1. And that would be our rectangular equation. And this makes sense. It's a parabola that's been shifted left 2 and up 1. There's a lot more that you can do with parametric equations, but due to the current circumstances, we're not going to be going through everything that you can do with them. I just wanted to give you an introduction to what is happening when you're dealing with parametric equations and how exactly they work. Hopefully that was helpful, and hopefully you can now sleep at night knowing that you know how parametric equations, at least a little bit, work. Thank you so much, and have a wonderful day, everybody. Bye.